Hello my dear friends and students. Welcome to session number 6 related to electrical machines under the subject where we have to see today or unit number 4 where we have to see the DC machine construction and operation of DC machine as well as its types. Okay, so all these DC machines generally works on the electromechanical energy conversion. What is this electromechanical energy conversion? The process of converting either electrical energy into mechanical or the mechanical energy into electrical form is called electromechanical energy conversion. Based on this electromechanical energy conversion, DC machines are further classified into two, that is nothing but DC generator as well as DC motor. So the basic definition for the DC generator as well as the DC motors are the machine or an electrical machine which converts an mechanical energy into electrical energy is called DC generator. Vice versa, an electrical machine which converts an electrical energy into mechanical energy is called DC motors. So in short, we can say that for DC generator, input is mechanical energy and output is electrical energy. Similarly, for DC motor, input is electrical energy and output is mechanical energy. So the construction of both DC generator and DC motor is basically remains same. So just look out on the construction of DC generator where we have yoke, which is nothing but the external covering, field winding, then commutator, then pole shoes, then shaft, armature, commutator, interpoles, etc. These are the construction or the important parts of DC machines. We'll see one by one this construction and we'll understand the operation. First of all, what are the functions of these parts? First one, yoke. As I told you earlier, it is just an outermost cover of the DC machine, but with this it protects insulating materials from harmful atmospheric elements like dust, moisture, etc. It prevents mechanical support to the poles. Also, it provides a path of low reluctance for magnetic flux to avoid wastage of power. Second part is nothing but the pole, which is further divided into pole core and pole shoes. So pole core is nothing but or a pole core can carries field winding which will produce the main magnetic flux. It directs that magnetic flux through the air gap to the armature core to the next pole. Next, pole shoes enlarge the area of this armature core which will come across the magnetic flux and which is necessary to produce a large induced EMF in the armature. Next part is nothing but the field winding which is mounted on that pole core, and we are going to give an external supply to this field winding. It carries current due to which pole R behaves like an electromagnet which produces necessary magnetic flux. It helps to produce the magnetic field or magnetic flux, that is exciting the poles of electromagnet. So it is either called field winding or exciting winding. Field winding is divided into various coils called field coils. These are connected in series with each other and wound in such a way that alternate N and S poles are formed around the pole cores. The total number of poles is denoted by P. Next part is nothing but the armature, which is again further divided into two parts, armature core and armature winding. Armature core provides an house for armature conductor or armature winding. Also, it provides low reluctance to the magnetic flux produced by field winding. Then next, armature winding. It is nothing but the interconnection of armature conductors which is present in armature slots. In case of generator, generation of EMF takes place in armature winding, that is when armature is rotated, it cuts the magnetic flux lines and EMF gets induced in that armature conductors. So to collect this induced EMF, we require this armature winding. Next one, commutator. the basic nature of induced EMF in armature conductor is AC. Then this needs to rectification in case of DC generator. So the device which performs this task is called as commutator. It collects the current from armature conductors and it converts AC alternating induced EMF into DC. And the last part is nothing but the brushes. To collect current from commutator and make it available for the external circuit in case of generator, we require these brushes, or to give an external electrical supply to the armature winding in case of motor, we require brushes. So this is all about the construction of DC motor. We'll have one more look on that DC construction. Just a minute. Yes, as I told earlier, this is the pole core, this is the pole shoe. On this pole core, field winding is present. This is the pole shoe which enlarge the area for the magnetic flux lines. This is the armature. On that armature there are tooths, so which is called armature tooths. Number of conductors are placed in this armature tooths, and this armature is mounted on a shaft. So commutator is over here, and this shaft, the armature core is permanently connected to the shaft. That means if armature core rotates, shafts also rotate. Okay, so this is all about the construction. Now we'll see the working principle of DC motor. DC generator. So first of all, we see the working principle of DC generator. According to Faraday's law of electromagnetic induction, whenever the magnetic flux linking with the conductor changes, an EMF is induced in that conductor. Now see how we can satisfy this Faraday's law over here. First of all, we are going to give the external supply to the field winding which is mounted on the pole core. Then this pole will act now as an electromagnet, so which will generate a magnetic flux in the air gap between this field winding and the armature. Now in the second step, we are going to provide external device, or externally we are going to provide the rotation for this armature. So for that we can use prime mover, for that we can use diesel engine, petrol engine, whatever. But we are going to provide external, that means mechanical power we are going to give as an input. What happens when you rotate externally this shaft? The armature core rotates. When the armature core rotates, conductors mounted in the slot or in the tooth of armature, they starts rotate and they starts cutting off magnetic flux lines. And according to this Faraday's law, whenever there is a relative motion between magnetic flux and conductor, EMF gets induced in that conductor. So according to this Faraday's law, when you provide the rotation to this shaft, the conductor cuts the magnetic flux lines and EMF gets induced in that conductor. The value of that induced EMF E is given by, or E is equal to BLV, where B is nothing but the magnetic flux density, L is nothing but the active length of the conductor. Active length means the actual length of the conductor which is actually in the influence of magnetic flux lines, and V is nothing but the relative velocity. So the magnitude of induced EMF in the conductor E is given by E is equal to BLV, and the direction of that induced EMF is given by Fleming's right hand rule. What that Fleming's right hand rule says? Fleming's right hand rule says that if you outstretched the first three fingers of your right hand, then first finger indicates the direction of magnetic flux lines, and if thumb indicates the direction of rotation, then middle finger or the larger one finger indicates the direction of induced EMF in the conductor. So according to this, we have generated an induced EMF in the conductors. Now whatever induced EMF is there, it is present in each and every conductor. So to collect at the output side, we required armature winding. To collect such induced EMF at the output side, we required armature winding. Now there are two types of armature windings we used in the generator. So types of armature windings, first one is nothing but the lap winding, and second one is nothing but the wave winding. So the structure of lap winding and wave winding, it is an alternating lap winding, means first conductor is connected with third one and third one is connected to second one is connected to fourth one. Like that, it is lap, it continues its rotation in the lap format. Second, wave winding. Wave winding is nothing but like a wave or like a W pattern. It will connect to the next pole of the conductor. So here For lap winding and wave winding, few points we will discuss. The end of each armature coil are connected to the adjacent segment of the commutator so that the total number of parallel paths in the lap winding is given by A is equal to P. But similarly, for wave winding, the number of parallel paths always given as an A is equal to 2. So this is a armature winding which we used to collect the induced EMF. Working principle of AC generator or DC generator we have just now discussed. Whenever there is a relative motion between magnetic flux and conductor, EMF gets induced in that conductor. Natural form of generated EMF is AC, and if you want to convert that AC into DC, you require a commutator. Remember this one. This magnetic field is produced by field winding because only one external supply we are going to give to the field winding. It generates a magnetic flux lines. Second input we are going to give as a mechanical input. So rotation of shaft, externally we are going to provide this. So as rotation of shaft starts, it cuts the magnetic flux lines and EMF gets induced in that conductors. So using armature winding, we are collecting this induced EMF at the output side. So magnitude of that induced EMF E is equal to BLV, whereas the direction of that induced EMF is explained by Fleming's right hand rule. So at the corner of this PPT you can see the Fleming's right hand rule explained for DC generator. So in this way we convert that mechanical energy into electrical energy. That's why it is a type of DC generator. Further part we will see in the next video. Thank you all.